Hi friends, I am Singh. This is question number 1, exercise 3.4 pertaining to trigonometric functions. This says find the principal and general solution of the following equations. So one is tan x is equal to under root 3. Now before I proceed further to solve this problem, it is better to clarify some of the points which will be useful for solving such type of questions pertaining to principal and general solutions. So first thing we have to refresh that in different 4 quadrants what are the values of trigonometric functions, that is sine theta or sine x, whatever you want to call, or cos x or tan x. So just to refresh that one, in the quadrant 1 all the trigonometric functions are positive, that is sin x, cos x, tan x and their reciprocals. In quadrant 2 sin x and cosecant x or cosec x are positive and others are negative. In quadrant 3 tan x and cot x are positive and all others are negative. In quadrant 4 cos x and sec x are positive, all others are negative. So this is going to be useful in all these type of questions. Then question arises, what is principal solution and what is general solution? Here it is important to know that this circle represents here the rotary motion of the anything in the universe, whether it is wheel or it is spinning of anything, whether it is energy, whether it is electricity is also rotating. Whatever we are getting sine curve, that is nothing but due to this rotary motion, and that rotary motion is produced due to because we are rotating the shaft in between the magnets, and that's why this becomes a sine wave. Sine wave is nothing, that is a representation of the circular motion of anything only. So that is one thing. Then principal solution says in one rotation, that is if we go positively, that is anti-clockwise, from 0 to 360, that is one complete rotation if we have, or 360 means 2 pi also. So from 0 to 2 pi or 0 to 360, if we have one rotation, then what is the position of angles or trigonometric functions? So that is known as principal solution. Then after that, because it is going to be rotary motion, it may have 2 rotations, it may have 5 rotations in the same position, it may have 10 positions, maybe legs, crows, n number of rotations can be had when the things are rotating or spinning. But basically again position of the angle will be decided by the principal solution only. Other rotation will indicate just number of rotations, nothing more than that, but position remains same. So here, as we have 4 quadrants, and each quadrant is having all the trigonometric functions, whether it is positive or negative. So it has been observed, as I told you, because all the trigonometric functions are positive in quadrant 1, and different trigonometric functions, they are positive in other quadrants. So because 4 quadrants and each trigonometric function is positive in 2 quadrants and negative in 2 quadrants. For instance, sin x is positive in quadrant 1 and sin x is positive in quadrant 2 also. But sin x is negative in quadrant 3 and quadrant 4. So which means it is positive in 2 quadrants and it is negative in 2 quadrants. Similarly is the position of cos x and sec x, which are positive in quadrant 1 and quadrant 4, and they are negative in quadrant 2 and 3. Similarly, tan x and cot x are positive in quadrant 1 and quadrant 3, but in quadrant 2 and 4 they are negative. So like that, each trigonometric function is positive in 2 quadrants and negative in 2 quadrants. So depending upon the type of question, whether positive or negative, our answer will change. And depending upon the position of the point which is moving, so this is a point, so this will represent AO, B will represent this thing, angle X. So this angle will also be changing, quadrant will also be changing, so values of the trigonometric function will also change. So now this is principal solution will be possible only within the one complete rotation of the anything which is rotating or circle. So that will give us principal solution. But here the condition is it should go from 0 to 360 or 2 pi degree in anti-clockwise we have to take, and because if you change the reference from if you take on the right hand side, then the things will change and the answer will change and there will be confusion. So to have a common thing and for a better comparison purpose, so certain rules are to be followed. So in this case it is one rotation, complete rotation, but anti-clockwise, and in that what are the positions of the trigonometric functions, what are the values of x, so that will give us principal solution. And what about general solution? The general solution is once you are having more than one rotation, then it is known as general solution because it may have 5 rotations, 10, hundreds, lakhs, crores, etc. But after each rotation it will come to the certain position. So that will be again decided by basic position will be same as in the case of principal solution, but here number of rotations will change. So number of rotations you can say so many number of rotations plus the position. So like that, that will give general solution, means which is applicable for any number of rotations, and only first rotation, one rotation will give principal solution. So general means that can be any number of rotations. So this is the difference. So I have in fact given the details in the separate video, and I have derived the values for the general solution, the values of x, that is angle, that is theta, or x. In this case we have taken as x. I mentioned the formulas on the next page. So those formulas will be useful for solving the other problems also. So the derivation of these formulas I have done in the separate video, for which the link of that I will give in the description of this video, so that will be useful. So why and how these formulas have been derived, and what is the interpretation of that is also equally important. Then this is about what is general solution I have mentioned, and now the formulas of the general solutions are given here. That is now the formula for the general solutions for the various trigonometric functions are given as, so when sin x is equal to 0 or tan x is equal to 0, then general solution is, that is the value of x is equal to n pi, where n belongs to integer, that is n belongs to z. So that where we are using n, we should mention this thing. And the second formula is cos x is equal to 0, then the value of x is equal to 2n plus 1 within the bracket into pi by 2, where n belongs to integer or n belongs to z. So n is an integer. So that we have to clarify here what is n. So this is for cos x is equal to 0. Now the sin x, tan x and cos x will not be only 0, they will be having other angles also, and their angles will be changing, and the values will be changing in the different quadrants, that is plus, minus, depending on the different situations. And after each rotation also there will be different value, that is due to the rotation of the wheel or any body which is rotating or spinning. So if the situation arises where sin x is equal to sin y is also angle, sin x is also angle, x is certain angle which we have to find out, and y is also different angle and different ways it is mentioned. So if this is a situation, is this not 0, then what will be the general solution? So in such a case, x is equal to n pi plus within the bracket minus 1 raised to the power n into y. where n belongs to integer, or it is an integer, or it belongs to z. That always we can mention wherever n is coming. And y is angle, just like x, it is also angle. Then question comes, cos x is equal to cos y. If this is a situation, then x is equal to 2n pi plus minus y. So general solution will be 2n pi plus minus y, where n is an integer. So this is applicable for number of rotations also. We can keep on changing n positively or negatively, whether the rotation is anti-clockwise or clockwise. Depending on that will give us different value. So then tan x is equal to tan y. If this is the situation, then solution of value of x will be, that is general solution, x is equal to n pi plus y, where n pertains to z. So in case of tan x, it is only plus y. In case of cos x, this is plus minus y. In case of sin x, this is plus, and within the bracket minus 1 raised to the power n, that takes care of plus minus both. So what is the interpretation of that? That also we'll discuss in some other questions, so that the thing should be clear. But complete details are given in the separate video, that you can go through that. So this is a question number 1. What it says, tan x is equal to under root 3. This is question number 1. So tan x is equal to under root 3. Now what is the value of tan x is given under root 3. And under root 3 is nothing but, it is tan 60 or pi by 3. Both are same. So it means in the first quadrant, the value of under root 3 is pi by 3 or tan 60, because now we are dealing with radians, so we will mention in radians only, that is in pi. And we also know that tan theta or tan x and cot x, they are positive in the first quadrant and the third quadrant. So when we say tan x is equal to pi by 3, so this is in the first quadrant. Then if it is in the third quadrant, it is positive, because the value is positive under root 3. So it will be only in the third quadrant. In the third quadrant, it will be, this is the position. In the first quadrant, this will be the position of point A, which is making an angle of x with the x-axis, that is OX, and this angle is angle x. So tan x is a tangent x of this angle, that is perpendicular divided by base, that is AB divided by OB. So this angle, when this point moves to third quadrant, then again it becomes positive. In the second quadrant it is negative, and in the fourth quadrant also value of tan and cot thetas or x are negative. So when it comes to this position in the third quadrant, this position, then again it becomes positive. So in the first quadrant and third quadrant, this will be the positions, and tan x will be positive. Now we know tan 180 or pi minus x or pi plus x, that will remain as tan x only. only it will change when it becomes tan 90 or 270 or pi by 2 plus 3 pi by 2 or pi by 2 plus x, or in the condition 3 pi by 2 plus x. If this is a situation, then it will change into sin x will change into cos x, cos x will change into sin x, tan x will change into cot x, and so on. So we want to retain the same value of tan x, so we will be only dealing with the x-axis, that is 180 or pi plus x or pi minus x situations, or 2 pi or 0 plus or minus x situations, that is along with the x-axis, because along the x-axis the values will not change, along the y-axis the value will change. So this is we have to keep in mind for all the questions of this type. Now when this situation comes, so tan x is equal to under root 3. So this is quadrant 1. Here the value is 0 oblique 360 degree oblique 2 pi at this point, starting point. And if we go to vertical side y-axis, it becomes 90 degree or pi by 2, and then it becomes 180 degree oblique pi on the x-axis. When again it is going towards y-axis negative side, that is 270 degree or 3 pi by 2. So like that it will change. Now we have tan theta is equal to tan x is equal to under root 3, which is nothing but, we can write it as, I will write on the next page. We can write it tan x is equal to under root 3, or we can write it as tan x is equal to tan 60 or 10 pi by 3. This is in the first quadrant. But we know that tan is positive in first and third quadrant. Tan x, we know tan x is positive in first and third quadrant. First and third quadrants. So this is one value we have received, tan x is equal to 10 pi by 3, or we can say x is equal to pi by 3. We have to find the value of x only, so x is equal to pi by 3. So second situation comes when tan x is equal to, third quadrant means that is pi plus x. So pi plus x is kitna? X is how much? X is pi by 3. So this is equal to pi, this is plus pi by 3, 3 pi, LCM is 3, 3 into pi, 3 pi plus 1 pi, so 4 pi by, this is 10. So tan x is equal to tan 4 pi by 3, or x is equal to, hence x is equal to 4 pi by 3. So now we have got the two principal values of the x, that is x is equal to, hence there are two principal solutions of x is equal to pi by 3 and 4 pi by 3, and the general solution of x in case of tan x is given as, what is the formula of that? So that is x is equal to n pi plus y, or x is equal to n pi plus pi by 3. Y is pi by 3 and 4 pi by 3. So any one of this we can take. So normally we take a smaller one. There is some reason for that also. So if you take n is equal to 0, because n can be positive, n can be 0, n can be negative also. So this becomes pi by 3. Then if you take n is equal to 1, this becomes pi plus pi by 3, that is 4 pi by 3. So this is it. These are the two values are principal solutions. So this is in the one rotation. Then if we take n is equal to 2, so this becomes 2 pi, and this is 3 into 2, 6 pi, this becomes plus 1, 7 pi by 3. So 7 pi by 3 is the next, this is after one rotation now. So it has completed one rotation, and again it has come in the original position in the first quadrant, where it was, the value was earlier pi by 3. So like that it will keep on increasing, but the position of the angles will remain same. Only if we are having more rotation, it will indicate number of rotations only, additional, nothing more than that. So that's why it is a general solution. It is applicable for clockwise, anti-clockwise directions of the spinning or rotating anything. So this is a general equation. So principal solution is a part of the general solution. This represents one complete rotation, while the general solution indicates any number of rotations, but the position of angle will remain same, except the number of rotations will be added. So this is the difference. So this question is over. Now we'll move to next question. So here, whenever we are using n, we should mention where n pertains to or belongs to integer, that is z. That always we should mention in the general type of solutions. So this is the answer for this question. I am again showing the formulas if somebody has missed it out or earlier it is not come clear completely, so I am again repeating it so that it should be visible. It will be useful for other questions also what we are going to deal with. So is the position of tan x is equal to under root 3, that is in the first quadrant, and this is in the third quadrant. It is like that. So after each rotation it will come in the same position, that is, this is the principal solution. Within first one rotation, whatever the positions we are getting, that is a principal solution. So this is now this is question number 2, exercise 3.4 pertaining to trigonometric functions. This says sec x is equal to 2. Now we have values for sin x, cos x and tan x, or sin x is equal to 0, or cos x is equal to 0, or sin x is equal to sin y, cos x is equal to cos y, and tan x is equal to tan y, and tan x is equal to 0. So all other trigonometric functions are reciprocal of these functions. So now we have sec x equal to 2. So that's why we will change into reciprocal, that is cos x, for which we have the value. So we will do one thing. First thing we will do, sec x is equal to 2 will convert into cos x. So sec we can write as 1 by cos x is equal to 2, or on cross multiplying, cos x will come this side, 2 will come in the denominator. So this will become 1 by 2 is equal to cos x, or cos x is equal to, we can write it as it is, 1 by 2. Now we know cos x is positive, this is x-axis, this is y, and cos is positive in the first, and cos is positive in the fourth quadrant also. So in this quadrant only cos is positive. So here the value is cos x is equal to 1 by 2, that is positive value. So we can write cos x as cos x is the value of, this is the value 1 by 2 is cos 60, that is cos pi by 3. So we can write cos x as 1 by 2, we can write, that is cos 60 or cos pi by 3. This is in the first quadrant. Or we can say, hence x is equal to pi by 3. So this is the value of x. This is one value. So there are two values because two positive, two negative. So another positive value is in the fourth quadrant, because cos x and sec x, they are positive in the first and fourth quadrant. So in the fourth quadrant, how we are going to represent? I said when we are going to start from 0 and we go up to maximum 360 degree or 2 pi, then one complete rotation will be there, and the angle in between this position will be from 0 to 2 pi will be principal solutions. If it exceeds number of rotation more than one, then that will be general solution we have to find, which will serve the purpose for all the rotations, positive or negative, or clockwise or anti-clockwise. So this is one solution now in the first quadrant. When it is in the fourth quadrant means it will be along the, and we can write cos x is equal to, in the fourth quadrant we can write it as 2 pi minus pi by 3. Where positive is pi by 3, negative is also pi by 3. If we take it, we can also show it as minus pi by 3 minus theta, but because we are taking one complete rotation one side, so we cannot change the rotation in between, because the rules and regulations should be same for all the angle, then only we can compare it. So then we have to take it, instead of 0 we will take it 2 pi minus pi by 3, while 2 pi and 0, they coincide with each other and they have the same values, so value wise there won't be any difference, but as a matter of principle, so to have a better comparison and to avoid any confusion, we should take as 2 pi. So 2 pi minus pi by 3, this becomes 3 into 2, 6 pi minus 1, so 5 pi by cos 5 pi by 3. So this is nothing but, this is cos only. So cos x is equal to cos 5 pi by 3, or we will say x is equal to 5 pi by 3. Now there are two values of x, that is pi by 3 and 5 pi by 3. If you could have taken negative value here, then both the values could have been pi by 3 only. Both are positive, because cos x is positive in the fourth quadrant. So they could have been virtually one value then. So that's why, because we are taking 2 pi, so this is giving a different angle, this is giving a different angle. So there are two angles of x, there are two values of x which are giving us principal solutions. So this is a principal solution, we can say. Thus the principal solution for sec x is equal to 2, or what are the values of x? Pi by 3 and 5 pi by 3. That is pi by 3 and 5 pi by 3. So these are the principal solutions. Now what are the now what is the general solution for sec x is equal to 2? The general solution sec x has been converted into cos x. We will say the general solution for cos x is given as x is equal to 2n pi plus minus y. So this is equivalent to, or x is equal to 2n pi plus minus, smallest one we can use pi by 3. If we use bigger one, then also we can get the answer, but we'll see how it will change now. Where n belongs to integer, that is z, we can say like that. Now if you take a situation where n is equal to 0, because n can be positive, n can be 0, n can be negative. So this becomes 0, this becomes, answer we will be getting plus minus pi by 3. When n is 1,